future tech. Upcoming advancement and quantum computing. The next wave of technology will not be only one invention. It will be a stack of breakthroughs arriving together. Artificial intelligence, robotics, new energy systems, advanced chips, synthetic biology, space infrastructure, and quantum computing. The biggest impact will come when these technologies combine. AI will help design materials. Quantum systems may help simulate chemistry. Robots will use better sensors and models. Energy innovation will power data centers and electrification. The future is not one tool, it is a connected system. The first major advancement is AI agents. A chatbot answers a question. An agent can work through a task, gather context, plan steps, use tools, create outputs, test results, and ask for approval. In business, this means customer support workflows, content production, research, software development, reporting, and operations can become faster. The important challenge is trust. Agents need permissions, monitoring, and human review. Robotics is improving because several ingredients are getting better at the same time. Computer vision, batteries, motors, sensors, simulation, and AI planning. Warehouses, factories, agriculture, healthcare, and home assistants could all change. The hardest part is the real world. Unlike software, physical environments are messy. Robots must handle uncertainty, safety, and cost. Progress will be gradual, but the direction is clear. Quantum computing is one of the most misunderstood technologies. It is not simply a faster laptop. Quantum computers use quantum states to process certain kinds of information differently from classical computers. The most promising areas include chemistry, materials science, optimization research, and future cryptography. IBM's roadmap points toward early examples of quantum advantage, deeper quantum classical integration, and eventually fault-tolerant systems. The key challenge is error correction. Quantum information is delicate, and useful machines need reliability. Energy and chips are the hidden foundation of the future. AI models, cloud platforms, electric vehicles, robotics, and quantum research all require advanced hardware and electricity. The bottleneck may not be ideas, it may be power, cooling, manufacturing capacity, and supply chains. That is why data center infrastructure, grid technology, semiconductors, and energy storage are becoming strategic industries. Biotech and space are also moving quickly. AI can help researchers search chemical space, analyze biological data, and design experiments. Personalized medicine may become more precise as sequencing and data tools improve. In space, reusable rockets, satellite networks, Earth observation, and in-orbit services can create new business models. The future economy may depend on both biological intelligence and orbital infrastructure. The future technology story is really a story about convergence. AI needs chips and power. Robotics needs AI and sensors. Biotech needs computation and data. Quantum computing may help simulate chemistry and materials. Space infrastructure creates new communication and observation layers. Each field strengthens the others. AI agents may become the operating layer for many businesses. Instead of opening 10 apps manually, a worker may ask an agent to prepare a report, check inventory, draft emails, update a dashboard, and flag exceptions. The value is not replacing every person. The value is reducing repetitive coordination. Quantum computing should be understood with patience. It will not replace normal computers. Classical computers will continue to run most business, media, and web tasks. Quantum systems may become accelerators for special problems, where quantum behavior itself matters, such as molecules, materials, and certain optimization questions. The bridge between today and useful quantum is quantum classical computing. That means CPUs, GPUs, and quantum processors working together. Classical systems prepare data, manage workflows, and interpret results, while quantum processors handle the parts where they may eventually offer an advantage. Energy will be one of the biggest constraints. AI data centers, electric vehicles, factories, and advanced manufacturing all need reliable power. That makes grids, storage, nuclear, renewables, gas turbines, cooling systems, and power electronics part of the technology story. For individuals, the best preparation is not to memorize buzzwords. Learn how systems connect. Understand data, automation, basic finance, cybersecurity, and communication. The people who can translate technology into useful workflows will be valuable even as tools change. One of the most important trends is that technology is becoming less separate from everyday work. AI is not only for software companies. It is becoming part of marketing, finance, education, healthcare, manufacturing, logistics, and customer service. The companies that win will not simply buy AI tools. They will redesign workflows around them. Quantum computing will likely arrive in stages. The first stage is research value, where scientists use small systems to learn. The second stage is hybrid value, where quantum processors work with classical systems in narrow workflows. The third stage is fault-tolerant computing, where error-corrected machines can solve deeper problems reliably. Each stage may create different business opportunities. Cybersecurity will also change. As quantum computing improves, governments and companies are preparing for post-quantum cryptography. This does not mean every password breaks tomorrow. It means long-lived sensitive data should be protected against future capabilities. Security planning has to look years ahead. Advanced chips will remain a strategic bottleneck. AI models, robotics, defense systems, scientific simulation, and cloud platforms all depend on compute. That makes semiconductor design, manufacturing, packaging, memory, networking, and cooling central to the next decade. The human skill that matters most is adaptability. People do not need to become experts in every frontier technology. But they should understand enough to ask good questions, identify real use cases, avoid hype, and connect tools to practical outcomes. The future belongs to people and companies that understand convergence. AI, quantum, robotics, energy, chips, biotech, and space will not evolve separately. They will reinforce each other. The opportunity is huge, but so is the responsibility. The next decade will reward those who learn continuously, build carefully, and use powerful technology with judgment.